Mars was not always a dusty and desolate world. There is ample evidence that the planet was once warm, had lakes of liquid water, and was habitable for a brief period in its history. Researchers now hope to find traces of this era inside the planet and answers to the question of why Mars changed so drastically. What they then actually discovered shows that Mars is still alive. What does this mean now exactly, also in view of the future settlement of the planet? And could Mars become a living world again through clever terraforming? Stay tuned, because we will now show you Mars from a completely unknown side. InSight's Mars mission. In 2018, the InSight Mars lander launched toward the Red Planet. InSight is short for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport. The lander was developed specifically to find out what exactly is going on inside the planet and how the core of Mars is structured. Now, you may think that this is not as exciting as exploring the surface and searching for traces of life or water. But the core has it in itself. It is only in the hitherto completely unknown center of Mars that researchers are finding the missing answers as to why Mars has developed into what it is today and why it has gone from being a possibly inhabited world to a dry wasteland. Using drills and special analysis equipment, the probe penetrates deep inside, taking seismic measurements and recording both the number and intensity of Martian quakes. In the strength of the quakes, researchers currently encountered a big surprise. How does the core of Mars differ from that of the Earth? To understand the explosive nature of InSight's findings, we must first look at the structure of our Earth's core. About 100 years ago, researchers first had the technology to scan Earth's interior in a very unique way. Scientists analyze seismic waves that travel through the Earth's interior. These waves are triggered by natural events, such as the movement of continental plates and even phenomena like earthquakes. As they travel through the Earth's interior, these waves encounter various materials. During the contact between material and wave, the wave takes on a very particular signature that scientists can later distinguish. Layers of rock alter the waves in a very different way than underground cavities or watercourses. Seismic waves occur mainly as P and S waves. P waves, or primary waves, are pressure waves that cause rocks to vibrate parallel to the direction of wave propagation. Because they are the fastest seismic waves, they are the first to arrive from the epicenter of the earthquake. S waves, or secondary waves, are shear waves that vibrate rocks perpendicular to the direction of wave propagation. They travel about 60% of the speed of P waves and arrive after the P wave has passed. In 1906, seismologists discovered that seismic waves travel much slower in the Earth's core than in other sections. Even more interesting was the observation that S waves did not penetrate the core, while P waves passed through it easily. Only at the boundary of the core did an interesting deflection occur. From these observations, the scientists were able to conclude that the inner core is solid, while the layer above it is liquid. The core of iron and nickel in the innermost becomes solid due to the high pressure. In 1936, researchers again found that seismic waves reflected off the inner core, indicating a transition from a liquid to a solid state. Thanks to these discoveries, we now know that Earth's core is composed of complex layers, and geologists have an advanced understanding of Earth's evolution. The connection between the Martian core and the magnetic field. Research on the structure of the Martian core revealed shocking connections between the planet's interior and the magnetosphere. Based on seismic data, the Martian core was found to have a liquid consistency throughout. In contrast, Earth's core consists of a solid inner core and a liquid outer core. The research suggests that the composition of the Martian core, particularly the presence of lighter elements, contributes to this phenomenon. While Earth has a strong magnetic field generated by geodynamo activity in the outer liquid core, Mars has a much weaker magnetic field. This relatively weak magnetic field of Mars has implications for the planet's ability to protect its atmosphere and minimize the harmful effects of charged particles from space. Earth is almost perfectly protected from the constant particle bombardment from the sun by its strong field, But Mars was hit with much greater harshness by solar winds over epochs. Unprotected, the particle streams from the Sun were able to affect the outer atmosphere of Mars and even eroded over millions of years. Together with cosmic rays, the Martian atmosphere was so significantly depleted that the planet is now virtually unprotected. Mars's lower gravitational pull and lack of a sufficiently strong magnetic field has also allowed charged particles to penetrate the upper atmosphere and trigger chemical processes there. This led to the release of gas molecules, including lighter elements such as hydrogen and helium, into space. The changes in the atmosphere in turn had an impact on the surface of Mars. While liquid water may have existed on Mars in the past, it largely evaporated or escaped into space due to the loss of the atmosphere and protection from solar winds. Computer simulations show that erosion by particle flows very likely contributed to the formation of Mars's distinctive geologic features. Today, the surface of Mars is characterized by dusty and rocky expanses, dried-up riverbeds, and vast volcanic areas. In short, we could say that Mars slowly dried up, and if there ever was life on it, it disappeared with the water and with the increase in radiation. Our Earth, on the other hand, was able to support life to this day because of its robust magnetic field and dense atmosphere. Yet today, in the face of climate catastrophe, we naturally wonder if such a fate also awaits our planet. The parallels between the effects of solar winds on Mars and current changes on Earth are unmistakable. Our human activity has resulted in more and more greenhouse gases being released into the Earth's atmosphere. If nothing changes, we will destroy our atmosphere ourselves, and our homeland will also be more and more exposed to the influences of the sun and the cosmos. Already today, the fragile ecosystems and the general basis of life are threatened. The comparison with Mars shows how delicate planetary balances are and how important it is to protect the Earth and find sustainable solutions. So, far from just opening up a potential new home for humans, the exploration of Mars also serves to better understand what is going on our planet and what consequences we should expect. But let's move away from the dramas currently unfolding on our home planet and look further afield to Mars. Mars is not as lifeless as previously assumed. On the contrary, a force is currently awakening inside the planet that scientists do not yet really know what it means for the future of the planet. Unusual Mars quakes alarm scientists. During its 4-year active phase, InSight detected hundreds of Mars quakes. But it wasn't until 2021 that things got really interesting. That year, InSight documented 2 unusual quakes on the opposite side of the planet. One was a massive Mars quake, larger and more powerful than ever recorded before, while the other was the result of a meteorite impact. These events, on the opposite side of InSight, were a windfall for science. The lander was now able to analyze waves that not only traveled around Mars, but also passed through it, once again providing researchers with new data and details about the structure of the core. Exactly this data completed the picture in a way that we now know Mars has a liquid core. But the findings go much further. Thanks to the new data, scientists were able to analyze the elements inside in great detail for the first time. It turned out that the core of Mars has a high proportion of lighter elements. Large amounts of sulfur, followed by smaller amounts of oxygen, carbon, and hydrogen, make up nearly 1/5 of the planet's weight. Exploration of the interior of Mars continued to be exciting. On May 4th, 2022, InSight recorded the strongest Mars quake ever measured. The seismic shaking of the Martian subsurface reached magnitude 5 for the first time. A quake of this magnitude would also be clearly noticeable on Earth, but for Mars, this event is a true megaquake compared to all previous shaking. Strictly speaking, researchers did not even consider quakes of this magnitude possible on our planetary neighbor. Why Mars is now suddenly shaking with this strength is a mystery that scientists will continue to investigate. The activities in the interior and the flare-up of the quakes show that Mars is far from dead, even if it appears so at first glance. In fact, it's quite possible that the planet will continue to change as it evolves, possibly due to the influence of us humans as well. A revitalized world thanks to terraforming? Elon Musk, the visionary CEO of SpaceX, has the ambitious goal of making Mars a second Earth for humanity. Among the most fantastic plans of key technologies to make this goal possible is terraforming. Terraforming stands for a process by which the environmental conditions of a planet are altered to make them more Earth-like and thus habitable to humans. Musk's plans for terraforming on Mars include an artificial greenhouse effect that could be ushered in by 2 nuclear rockets detonated over the Martian poles. The carbon dioxide then released would, by pure calculation, create a greenhouse effect and raise temperatures on Mars. A warmer environment would release frozen water and further compress the atmosphere, which in turn could further drive temperatures. In addition to the nuclear option, Musk has proposed placing advanced solar sails or mirrors in orbit around Mars to direct more sunlight to the surface and accelerate warming. Terraforming, despite these already detailed prospects, is a complicated process that could take centuries and involves many unknowns. The latest findings about Mars's weak magnetic field and liquid core may now present more unexpected obstacles to Elon Musk's plans. Experts fear that despite all efforts, Mars would lose liquefied water so quickly that no significant atmosphere and climate with a closed water cycle can develop. But how do you see the current developments on Mars? Do you think goals like terraforming are feasible and even important for us humans? Or do you rather think we should leave Mars as it is and take care of our own planet?